Question 4 says f of x is 4x minus 7, g of x is 3x plus 1 over 2. Find the value of g of 0 plus g of 5. Easy question. G of 0 means we're going to substitute x as 0 in this function to get 3 times 0, which is 0 plus 1 over 2, plus g of 5. G of 5 means we put x as 5. 3 times 5 is 15 plus 1 over 2. All right, so now when we go ahead and add them across, now what we're getting is 1 over 2 plus 16 over 2. 16 over 2 is 8 plus a half, that's 17 over 2. So we're getting 17 over 2. Nice and easy. 17 over 2. Then we need fg of 5. fg of 5. fg of 5 means we put g of 5 into f. But look at this, we just work out g of 5 and we said that g of 5 is 15 plus 1 over 2. 15 plus 1 over 2 is 8. That's 16 over 2, which is 8. So what we're going to say is fg of 5 is equal to, when you work out g of 5, you're getting 8. So fg of 5 is f of 8. So all we need to do is put 8 into f of x. So putting in 8 into f of x, we get 4 times 8, because x is 8, and then we take away 7. That is fg of 5. 8 times 7 is, 4 times 8 rather is 32, and 32 minus 7 is 25. All right, and so fg of 5 is 25. That has a nice ring to it. Say it with me one more time. fg of 5 is 25. I like how that sounds. fg of 5 is 25. Nice. Now it says find f inverse of 1. Now, there are many ways you can do this. You can find the inverse function and do that, but I'm going to show you the easier way. All right. Now, just to recall this, if f of x, just to remember this, if f of x is equal to n, then f inverse of n is equal to x. So what am I saying? I am saying instead of solving f inverse of 1, f inverse of 1 is equal to x. It's the same as solving f of x equal to 1. So it's a lot easier if we solve f of x equal 1 and solve for x. All right, instead of solving f inverse of 1. So f of x, as we know, it is 4x minus 7. And so we're setting 4x minus 7 equal 1. So if 4x minus 7 equal 1, then 4x must equal to 8. And if 4x equal to 8, then x must clearly be 2. All right, so f inverse of 1 is 2. Nice and easy, soft. So x equal 2. Nice. Now here's this question now. It says P and Q. P is 6, negative 1, and Q is 2, 7 are endpoints of the line segment PQ. It says determine the gradient of PQ. So I want to determine the gradient of PQ. So this is fairly simple. To determine the gradient of PQ, all right, to determine the gradient of PQ, we're going to have the gradient of PQ is equal to y2, let's start 7, y2 minus y1, so it's 7 minus negative 1 over x2 is 2 minus 6. All right, now 7 minus -1 is what? Positive 8. And then 2 minus 6 is what? -4. And so the gradient of the line PQ, well, the gradient of PQ is just -2. Nice and easy, soft. Now it says find the coordinates of the midpoint of PQ. So I like to call it M, MPQ. So I use common letter M for gradient and I use capital M for midpoint. So the midpoint of PQ is going to be x1 plus x2 over 2, x1 plus x2 over 2, comma, y1 plus y2 over 2. This is midpoint formula. But we're going to have to go back and look what is x1 and x2. x1 is 6 and x2 is 2. So it is x1 plus x2 over 2, which is 6 plus 2 over 2. And then you have y1, which is -1, plus y2, which is 7 over 2. So I'll work it out. The midpoint is actually 6 plus 2 is 8. 8 over 2 is 4. So it's 4, comma, -1 plus 7 is 6. 6 over 2 is 3. So that's 4, 3. So that is the coordinates of the midpoint of PQ. Now it says find the equation of the perpendicular bisector of PQ. Now in order to find the equation of the perpendicular bisector of PQ, what is this perpendicular bisector? So what I want to do is picture a line, all right? This is P and this is Q. So if you have some graph, right? I like when you see it graphically. If you have some graph, all right, Q is a point 2, 7, +2, +7. All right, Q is up here and P is, so this is Q, +2, +7. And then Q is 6, -1. All right, so let's say the line looks something like this. So this is the point Q, +2, +7, 2, 7, and P is the point 6, -1. This is P. And they want the perpendicular bisector of PQ. The first thing about the perpendicular bisector is that the perpendicular bisector, as the name suggests, this perpendicular bisector is perpendicular to the line PQ. All right, so the perpendicular bisector of PQ is going to have a gradient that is the negative reciprocal of QP, and also the perpendicular bisector passes through the midpoint of QP. All right, so what is that telling us? So they're giving us the gradient of the perpendicular bisector. I like to call bisector B. So the gradient of the perpendicular bisector B is equal to -1 over the gradient of the line PQ, which is -2. -1 over -2 is a half. So the gradient of the bisector is a half. All right. So now the equation of the bisector is y equal mx plus c. All right. But we don't know what is plus c. So how are we going to find c? Well, we do know that it passes through the midpoint 4, 3. And so when y is 3, we have a half. This should be plus c. I put plus 3. That's crazy. It should be plus c. So 3 is equal to the gradient, which is a half, times x. The gradient, which is a half, times x. And x in this case is 4 plus c. So it's a half times 4 plus c. All right, so all we have to do now is a half times 4 is 2. We subtract 2 from both sides and we get 1. And so c is equal to 1. C is equal to 1. So then what is the equation of the bisector? The equation of the bisector is y is equal to the gradient of the bisector, which is a half x plus a constant 1. That's the equation of the bisector of PQ. Nice and easy, soft. And this takes care of question 4.